Moment of inertia of a hollow sphere about an axis passing through the diameter. Suppose this is a hollow sphere having mass m and radius r, and there is an axis which is passing through the center of the hollow sphere. So the moment of inertia of the hollow sphere about this axis will be 2 by 3 mr square. If we have a solid sphere, again the solid sphere has mass m and radius r. This is the axis. The moment of inertia about this axis which is passing through the diameter is 2 upon 5 mr square, where m is the mass of the solid sphere and r is the radius. After solid sphere, we have a hollow cylinder. Now suppose this is a hollow cylinder having mass m and radius r, and the axis of the cylinder is the very axis about which we have to find the moment of inertia. Now what we can do is, if suppose we splice this cylinder into n parts perpendicular to the axis in this manner, then we will get many rings. And for all the rings, the axis is passing through the center and will be perpendicular to all the rings. So the moment of inertia, suppose, of the first ring will be m1r square. For the second ring, it will be m2r square. And in this manner, if we have n rings, then the moment of inertia of the nth ring will be mnr square. So the total moment of inertia will be sum of all the masses, which is capital M into r square. So we can see that the moment of inertia of the hollow cylinder is the same as the moment of inertia of the ring, because a hollow cylinder can be considered to be composed of many rings. Now if we come to the solid cylinder, suppose we have a solid cylinder. So this is a solid cylinder. It is the same as the hollow cylinder except for the part that it is solid. And if we draw the axis of the cylinder, this axis is the same axis about which we have to find the moment of inertia. If we again cut this cylinder into n smaller parts, each part will behave as a disc. So the moment of inertia of the first part, I'll write the total mass as m, radius as r. Moment of inertia of the first disc will be half m1r square. Moment of inertia of the second disc will be half m2r square. In the same way, moment of inertia of the nth disc will be half m n r square, and if we add all of them, we get the total moment of inertia as half capital M r square. So we can see that the moment of inertia of the solid cylinder is the same as that of the disk.